Welcome back, everyone. Nice to meet you here, my audience from YouTube. So, in this video, I continue with solving radical equation from the previous video before, except that I will show you how to solve it and check both graphically and algebraically. Again, just to advertise for my courses online, you will go to mathcourses-online.teachable.com. That is my mathematics online school, and my math courses I have created and developed it in the past 3 months. My first two courses has been published, Calculus 1 Introduction and Introduction to Calculus 2. I hope that my course online will serve you well. If you're watching me from YouTube and you like the way I explain as well as the way I show you how details, how information of the mathematics look like. Now, regardless what level you are in, maybe you're at level of Math 12, or maybe entering the college or university. As I mentioned that there never have been such a push for mathematics education, especially we are in the digital revolution world. We are online now, and when the internet booming, and you will see how the internet, the digital world has changed and shaped the form of our education structure. Online education is the best education because it serves you as an individual student. Tutoring one-on-one, especially for young adults, online education helps you to be self-motivated in learning, and that's the key of your success. Time management help you in terms of self-directed in terms of time management, and another key of your success. So we are online course creator, try our best to give you the best qualified education. I'm done my advertisement now. So let me get into my lesson today. On the board, I put my example 1 is square root. We're going to solve this equation. And this equation is just normal radical equation, but we will do it in both algebra and graphically. I'm going to do algebra first, right? So we're going to solve this equation. And remember the step I show you in the equation. First, we should state the restriction, right? State the restriction. So what is the restriction in here? We'll say x plus 5 because whatever inside here have to be positive, which is bigger or equal 0. Move this over, x have to be bigger or equal -7. So this is the restriction we keep in our mind, right? That's the restriction. So now we will square both sides. And when we square both sides, the reason we square both sides to remove the radical sign, right? So the power here will cancel out with the root here, and this expression come out nicely. Unfortunately, we create a new algebraic expression, which is x minus 7 multiplied with x minus 7. because we have power 2 here. But I'm going to use the algebra formula, right? This will be equal to x squared minus 2 times 7 times x will be 14x. That's how I use the formula. This will be plus 49, 7 squared. So that becomes 49. So now I am going to move everything here to the right-hand side. So I left with the left side is 0, and this will become x squared. Positive x move to here will become negative x. Add to here will be minus 15x. And the 5 move here will make this become negative 5. And 49 subtract 5 will be positive 44. So by looking at this algebra quadratic function, because the degree 2, I know I can factor out this. By split this become 14. Okay, so if I split this, I will make it become 44 will become, divide by 4, I will get 11, right? If I divide this by 4, I get 11 times 4. So that will split this into 2 factors. And I have to assign the correct side for this. It should be minus 11, this minus 4. So I can add them, become minus 50. That's how I factor, right? So I have 2 brackets. Now, if you learn at this level, you already know how to solve the quadratic equation, whether using formula or using factor like this, right? So if we use factor, we divide this number into 2 terms, and we have to choose the term in such a way that when we add these 2 terms, we get back to the midterm here. So we have to assign the correct sign for these 2 numbers. So it got to be minus 11. And in here, another x, it got to be minus 4 when you toss in here, right? So that's how you factor it. And so for this, you will set each bracket equal 0. So x minus 11 equals 0. So therefore, move it over, x1 will be equal 11. And you set the second bracket equal 0. When you move it over, x2 will be equal 4. So now we will answer like this. This is the solution. However, remember, I told you that in radical equation, after we solve, we have to check whether or not our solution has an extraneous root or not. So let's check it, right? So I will say check left side equal right side or not. So let's say for x equal 11, then our original equation will be x plus 5 equal x minus 7. So this is our left side, our right side. Now, when you're checking the radical equation, make sure you check back to the original, right? Not any middle step we were doing it, but pick up the original to check. So the original here is this expression, x plus 5, the right side x minus 7. So I'm going to check if x is 11. So I put it in here. 11 as 5 will be 16. And we have the answer of this will be number 4. Take out the root. Now 11 minus 7 in here will be 4. So yes, the number 4 equals 4. So this answer is okay. So now for x equal We have two solutions here, right? One is 11 and one is 4. So for x equal 4, let's check it. We have 4 at 5 is 9, which is equal 3. Now here we will have 11, our x is, the second solution, our x is 4, no, our x is 4, yeah, that's right. So we substitute this by 4, minus 7, we'll get minus 3. So obviously we see that we have one is positive 3 and another one is negative 3. So this is not going to work, so we say reject. So the answer, this one is okay, and this one is reject. So we only can have one solution. And therefore, in radical equation, you have to try to make sure you check to see if which solution is working, which one is not. So now I'm going to show you how we will solve this equation by the graphically. So again, when we solve by graphically, we will, when we solve graphically, we will use a linear function, right? That's the easy way to sketch this function. So we're going to use a linear. And based on our radical algebra, we know our root is 11. So we might adjust the scale, follow that. So 11, so I'm going to make this is 2 and 4 and 6 and 8 and 10 and 11, right there. And our, that would be minus 2 and minus 4, so on. So our y, we have, if we sketch this linear, right, we assume that our linear is x plus 5, so let's do that first. So we have 5 as a y-intercept. So I'm going to make here is 2, 4, and 5. So this 5, right? And we mark that. Now our slope will be go up by 1 and go across by 1. And so that will go down by 1 and go across by 1. So our linear will look like this. Linear function will look something like this. So this is the linear. Now based on this, we can sketch the shape of our radical function. So the shape of our radical function, remember anything down here, we don't care, right? We cannot take negative of y value. So start from here will be our radical. And if, let's say, if square root of 5 will be 2.41 or something, let me see. Square root of, let's do a little bit accurate, right? So let's see if we take square root of 5, 2.23. So this is our 2.23. So this is 2.5, 2.23 is about here, right? What else? If we take the square root, let's say, if we take the square root of 11 and see what happened. Square root of 11. No, I'm going to take the square root of, if x equals 11, then this will be 11 at 5 will be 16, and square root 16 is 4. So if x is 11, our square root will be 4. So it's somewhere here. So our radical function will look something like this. And this point here is 11 and 4 for y. So that is our radical. This is the radical, right? We already learned how to sketch it based on the linear function. So this linear function is just the way how we use it to be able to sketch the radical by hand easily, right? Now, that is the left side, right? Solving equation, it means you have to figure out if this left side equal right side, then what is the x value, right? What is the x value of this function? So we have to sketch the linear x minus 7 to find the solution. So for x minus 7, we know that our y-intercept will be start from minus 7. So let's say this is minus 2, and this is minus 4, and this is minus 6. So minus 7 is somewhere down here. And we have the slope of 1, so we go up 1, go across by 1, go up 1, go across by 1, go up 1, go across by 1. So this is our linear. And this should be a solid linear because we're talking about the second function on the right-hand side, right? Now, obviously, very accurate. You see that this is the y equal x minus 7. And the solution for this right here, it intersects the radical form as this point. And there's only one solution. So based on this graphically, we find the solution for the right side of the equation, which is this linear, and the radical on the left, which is this radical function. And exactly our solution will be x will be equal to 11 and y will be equal to 4. But when we solve for this equation, we're talking about x value, right? We don't have to worry about y value. Now, let's examine if we do it by algebraically, we got reject for the second solution because the left side equal 3 and right side equal minus 3, and which is we reject the second solution. And obviously on the graph here, you can see that it only appears as one solution and not two solutions. So either way, we solve by algebraically or we solve graphically, we get the same answer. And it means that for this equation, there's only one solution. The other one is extraneous roots or the rejected root. We cannot accept that solution. And therefore, when we sketch it, it appears on the graph only one solution. So that is the beauty of math, right? We can do it either way and we can check it and exactly true. So now, let me show you another example. And I need to erase this, right? So I'm going to have to erase this. Or I'll show you another example. And both graphically as well as algebraically as well. So let me show you the second example. And bear with me, I have to erase the board. I don't want to bother to record another video, so just give me a second. It's just like I'm teaching in the classroom, you still have to wait for the teacher, right? So, okay. So let's see what is our second example look like. So the next example I want to show you, and I'm calling this example 2. We're going to solve square root of 3x squared minus 4. So this is a parabola inside the radical, right? So a little bit different, equal x plus 5. And we're going to solve both algebra and graphically as well. So let me do algebraically. Let me check, make sure I write the equation correctly. 3x squared minus 4 and x plus 5. Good. So again, we're going to state the domain for this. So we're going to say 3x squared minus 4 have to be bigger than or equal 0. So 3x squared will have to be bigger equal 4. Divide both sides by 3. It means x squared have to bigger equal 4 over 3. And 4 over 3 equal 1.33, right? 1.33. Yes, because we can change this into a mixed number, right? So 1.33 is the answer. Now, we're going to take the square root of both sides, solve for it. So the x squared have to be bigger, square root of 1.33. Got to be bigger 1.2 if we draw it up, right? So got to be bigger than 1.2. But also because remember when we take the square root of this, we ended up with 1 is positive and 1 is negative. So it means x have to be bigger than or equal 1.2, but x also have to be bigger than or equal minus 1.2. Now, actually, okay, we want the x got to be bigger equal positive 1.2, and x have to be okay, when we solve this inequality, we got to be careful, right? Because what had happened is okay, the way I shown this, I'm going to say, to make it easy, okay, so we just say square root of this number is this number. But we have positive x and we have negative x. So positive x have to be bigger equal 1.2. And negative x have to be bigger equal 1.2. But because we don't want to have a negative x, right? When we solve for inequality, we want this to be positive. So therefore, we have to twist the sign of this. of this and of this. That's the way we solve for inequality. So x have to be less than or equal minus 1.2. This is one condition, and this is another condition, right? So this is how we state the restriction. All of this is just the restriction. Now we're going to solve this. So to solve this, I'm going to square both sides, right? So we're going to square both sides to get rid of the radical. So we have the result of this number equal, this will be, square this will be equal x squared. I'm going to use a formula plus 10x and plus 25, right? That's how you open this bracket and of the quadratic function. So now we're going to have to solve for this one. Now I can see this is 1x squared. If I move it over, I will take away 1x squared. So this will become 2x squared. 10x, if I move it over to the side, I'm going to toss everything here to the left side, right? So that will become 2x squared minus 10x. And when I move this 25 over, it will be minus 29. Because that will be added into this minus, and that equals 0. Now, this is an unfactorable expression because this is a prime number, right? 29 is a prime number. You cannot factor it. So we're going to use a formula. And let me review for you a formula a little bit. I know some of you might know it, right? Let's review it. So x here will result in x1 and x2, right? Will be equal negative b adding subtract square root of 4, no, square root of b square minus 4 times a times c, all of this over 2a. That is the formula. So I'm going to use this and solve for this. So our x1 will be equal minus 10 will be positive 10. And subtract b squared will be 100 minus 4 times our a is 2 times our c is negative 58 and divided by our 2a is 4. So we ended up with x1 will be equal the 10 here, adding with all of this expression, right? And all of this expression will be equal, if you key in the radical first and you say 100, adding with, because the negative times negative become positive, so adding with 4, times with 58, and we're going to take out square root. That will give you 18.22, right? So our first x1 will be 10, adding with 18.2 divided by 4. So we're going to add this number into 10 and divide it by 4. We get 7.1. So x1 will be equal to 7.1. Now, our x2 will be equal 10 minus 18.2 divided by 4. So 10 minus 18.2 divided by 4 will be equal minus 2.1. So x2 will be equal minus 2.1. So that's the answer on my graphing calculator, right? Okay. So now let's check it, right? So we're going to say checked. So for x, equal, the first root is 7.1. We have left side and right side. Our left side will be equal 3 times x squared, right? Follow this expression, 3 times x squared, and now x squared is 7.1, so 7.1 squared minus 4, and let's see how much it equals. So I'm going to key in square root of 7.1 square times with 3 and then minus 4. So the answer is 12.1. Okay, so let me see. 7.1 square times 3 minus 4. So take square root of 147.23. Yes, 12.133. So the answer is 12.1. So that's our left side. Now, what is our right side? Our right side is, we say our root is 7.1. So we substitute for the right side, 7.1 add 5. And exactly, it equals 12.1. So it's okay, right? So that's one solution. Now let's check the other one. For x equal minus 2.1, we will have square root of 3 times with minus 2.1 square minus 4. And let's see how much it will be. So 2.1 square times 3 minus 4 be 9.23. So we take square root of 9.23. The answer is 3.3. The answer is just 3. So we're going to substitute our root as 2 minus 2.1 into the right-hand side. So on the right-hand side, we have minus 2.1, adding with 5, how much it will be. Minus 2.1 plus 5. The answer is 2.9. So it's very much almost like, almost the same. So 2.9, it could be round off, become 3. So the 3 and 3. So it look like both solution is correctly. But let's see how we graphically and see what it look like. Okay. So now this is a little bit tricky in terms of sketching it by hand, right? If you use it in the roughing calculator, you can use this in this case so that you don't have to sketch by hand. But sketching by hand still look like okay, we can do that as well. But let's check if I key in. Let's check the roughing calculator first to see what the rough look like, right? Now, before I check it, I'm going to make sure I get rid of the memory. Reset. So number 1 on RAM, 2 reset. So I make sure my gram is clear for roughing calculator. Now I'm going to key in the first equation will be square root of 3x squared minus 4. Close it. And the second equation will be x plus 5. And I'm going to sketch. So this is how it looked like. Now the graph looked like up this way a little bit, right? To the right. So I'm going to adjust the window. I'm going to say our window, I'm going to move the window down a little bit. So the x look like the same, but the y X maximum, let me change it to 15. And this is 1. The minimum, I'm going to change it into minus 5. And the Y maximum, I'm going to change it in 20. Yeah. Okay, so let's see how the graph changing. Okay, so this is the shape of the graph on my graphing calculator. Now I'm going to sketch it by hand and see, can we make it look like that a little bit. So I show you both hand and, so we're gonna sketch this left side first, right? So remember I told you the hint here, we're gonna assume that y equal our quadratic function, and our quadratic function, this is how it look like. So our quadratic function will be skinny one because you stretch the y vertically by 3 factor of 3, and you move it down, you move the origin down by 4 units. So let's say this is minus 2. Let's get this is minus 2 and this is minus 4. So this is 2, 4, 6, 8, come up here, 10, I might have to scale it. Okay, just leave it for now. 12, let's see. So now I'm going to have the x, and the x will be, let's say the x here is minus 1 this way, 1 this way, 2 this way, 2, 4, 5. Okay. All right, so how we're going to get this parabola? Now we know that if x is 1, our y will become 1 square times 3 minus 4, which is minus 1, right? So if x is 1, our y will become minus 1. So it down here a little bit. Okay, why don't we just sketch the basic shape and we're going to do the transformation, right? So our basic shape, or we can plug in the point, doesn't matter. So if x is 1, y is 3 times 1 is 3 minus 4 is minus 1. So I'm going to put here this 1 point on our parabola. If x is, let's say 2, will be 3 times 4, right? Minus 4 will be 12 minus 4 equal 8. So if x is 2, our y is right here. That's not point. And if x is 0, then our y will be minus 4. So that's the point. Now the parabola is symmetrical, right? So we know that our parabola will have another point look like this on the other side, right? Here, this point will be like this here. So that's how our parabola look like. And our x-intercept, based on this, we can adjust a little bit, let's cheat it a little bit. Our x-intercept x1 is, no, this is the solution. Our x-intercept is 1.33, 1.2. Yeah, so it very much is over a little bit, right? So it's over a little bit, but very much correctly. So So a little bit this one, kind of more round shape. So this is our parabola. However, we take the square root of this parabola, right? So square root of 4 is -2. No, square root of -4, we cannot take it. So this part is not accepted. So it starts from here. So if square root of A, let's check what is square root of A. Where's mine? Okay. So square root of A is 2.8. So at this point, I will act the same, let's assume that, but for the radical, square root of A is 2.8, so almost 3. So this is 2, right? And my scale is 2. So that 2 and 2.8, so it's about here. And symmetric, so it will go this way. So now we have, let's say if we have take the square root of 16, so if the point 8, 10, 12, 14, 16, 16 our point of this parabola about here, square root of 16 is 4. So 2, 4. So it's about like this, right? And should be down here 4. So it's about this way. It's about this way. So our radical look like this, right? Move to this 2 point. And the side look like something like this as well. And that's how our radical shape look like. Okay. So now our next step is testing x plus 5. So the x plus 5, so our intercept is the linear x plus 5, so this is 4 and this is 5. Now this going up 1 and go to, going up 1 and go to 1. Going up 1 and go to 1. So our linear will be, so at 5 we go up 1 and we go to 1. So this is the point. And then here we go up 1 and we go to 1. So our linear look like something like this shape. And at some point they will meet the two radical, right? This radical. Now, if I make this higher a little bit, at some point when I extend it, it will hit somewhere. What is our first solution? Our first solution is x equals 7.1. So that 2, 4, 6, and 7 is about, sorry. What do I mean? 1, 2, 3, 4, 5, 6, 7. So 7.1. Yes, it's about where they meet here if we draw a little bit accurate, right? So they will hit here at act at 7.1, right? That point and y, whatever, we can calculate the y as well. Now, what is the point where they hit here? When this radical meet this point here, it looked like our second solution minus 2.1. So yes, it's up a little bit, but this solution is minus 2.1 for x, and that is true because that's the way, right? How we sketch it and we shape it. So both solutions actually working well. and on the graph as well as the solving by algebra. So I hope that you find this video interesting enough to watch online. um, so I perform the graphically compared solution and show you how to restrict the domain and how to sketch this. This is the curriculum in the lesson in BC curriculum in Canada. You will learn about the function and things. So I hope you enjoy our video, and goodbye for now, and we'll see you in the next video. In the next video, I will move forward to, I will end the unit 2 here of the radical function, because we will learn a lot of function in the pre-calculus 12. We'll learn radical function, we'll learn polynomial function, rational function, and on the sketching like this. And you will see more interesting when you get deep into the details of the curriculum. Now, the rational function might be a little bit tricky, right? It's harder than radical function. And we also learn absolute function as well. There's a lot of function we learn. Not even to mention in logarithmic function, there's a lot of problem solving, right? Both algebra and word problem. And I hope that you will enjoy this Math 12 level. Also, if I go deep in, we will talk about the permutation and combination as well. So stay tuned for my math program. You will learn a lot of information from my videos, whether you watch it on YouTube. The benefit when you sign up to my course online, you have on the material layout to you and perform it presently nice on the MS PowerPoint presentation. It's a lifetime lesson learning. So math course online are different from our CD and textbook we learned before, definitely, because this is a live lecture video, show you step by step, right? And also it's exactly the way you learn in the classroom, except that sometimes in the classroom we have it so-so distraction. And here you have your own space, you can learn fast, you can learn slow, you can rewind, you can rewatch, you can relearn. So the benefit of it is huge. Everything have disadvantage and advantage, but we like to talk about the positive thing, right? So on the online course, you're more directed learning, you're more self-motivated, and you're more focusing. And you lost a little bit of social contact with your friends in the school, but we don't mix up. When we play hard, we learn harder. When you learn harder, you should focus, you should be on your own, and you should focus. So it's nothing wrong with the online learning. I hope you enjoy my video. Thank you for watching, and bye for now.